Light is everywhere.
Light can carry pictures and sound. We wouldn't have color without light. We need light to see.
Light is everywhere.
Light is everywhere. We never really think about it because when we can't get it from the sun, we can just flip a switch. But light is an important part of our daily life. There's even a part of science dedicated to light and what it can do. It's called optics and photonics. Optic means eye. The study of light is called optics. It's a part of physics. Physics tries to explain nature. Things like what makes a rainbow, why the sky is red at sunset, and the color of butterfly wings. And optics creates solutions to everyday problems. Cell phones, digital cameras, solar technology, CDs, DVDs, astronomy, and GPS tracking. Optics and photonics make all these things happen. The study of light allows us to see further and closer, in more colors and in greater detail. It's allowed us to harness light to help us save the planet, cure disease, talk to each other, and so much more. To help us because we know that light follows some basic rules. One of the most important things to know is that light travels in a straight line, and one of the best examples of this is the camera.
Light travels in a straight line.
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 To see light travel in a straight line, you'll need scissors or an X-Acto knife, tape, 2 dark pieces of cardboard paper, and 1 piece of wax paper. Next, you put it all together.
On this black piece of cardboard, we are going to have to make a 5.5-inch hole in the middle, which is going to make a screen for our wax paper. So now that we've cut out this frame, we're going to need to cut out the wax paper that we're going to tape behind it. This should be about 7 inches by 7 inches, and it should be fairly square so that you have a little room on the frame that you can tape the wax paper to. So first we're going to tape one end, and then we're going to do the opposite end so that that one stays tight and there are no wrinkles in it. So for the pinhole lens, you're going to take your other 8 by 8 inch piece of cardboard. Now with the safety pin, you're going to try and basically find the middle, and then with the pin, you're going to puncture a hole right in the middle so that you have just this tiny little hole.
Here's what you need to do next.
Hold out this pinhole about 2 feet away from the bulb. Then what we're going to do is we're going to take this, which is our sheet, and we're going to hold it out 2 feet away from the pinhole. Okay, what do you see?
Like a little upside down light bulb.
Yeah.
Like kind of like you know how they have the little screw in part and it's flipped up.
Now when I move it farther and back, now how do you see it change?
You should see a dim upside down image of the light bulb. If it looks like a smudge to you, move the screen closer to the pinhole.
So what this is showing is that all the light's going through the little pinhole, and since light goes everywhere, only a little bit of that light is being able to come through here. So when it's coming in, this top part, that light goes in at an angle and comes out this side, so that this light is on the bottom. And this light comes in at an angle from this side and this light is on the top. So it gets completely flipped around.
Yeah, that's really interesting. That's cool.
Yeah. Think about a pinhole camera. Where would a pinhole camera be on your body?
Like your eye?
Yes, your eyes. Your eyes actually do see things upside down. And your brain is like that big exposer thingy, and it flips it back so that you see everything right side up.
Since light travels in a straight line in all directions, the only light waves that travel through the small pinhole will be entering at an angle. This angle is what causes the image seen on the screen to be upside down. If you make the hole bigger, it should make the image brighter but less sharp. All camera designs, from the simplest homemade box camera to the newest digital camera, combine the same basic elements. Photography, lighting, telescopes, and microscopes exist because light travels in a straight line. Light is made up of many colors, and that fact is used to help astronomers figure out what's in stars, the sun, and the atmospheres of planets. Optical engineers make things that use light to change the world. We can solve problems with light. We can make the world a better place. What amazing things could you do with light?